Hello students, I welcome you all in this class of grade 7 for mathematical reasoning. Today we are starting chapter 1 surds and indices, and the exercise we will do is exercise 1.1. So let's start with our first question. Our first question is 16 base to the power 3 by 4. As you can see, there are two numbers. One is written in the normal format and one is written slightly higher than that text. So this 16 is called as the base, B-A-S-E, and the text which is written upside is called power or as an exponent, E-X-P-O-N-E-N-T, right? So I'll say it as 16 to the power 3 by 4. So let's start how to solve these questions. You just need to check your base, it is 16. You need to break it off into its factor and make sure when you are doing it, you are breaking into a factor of a single number for 4 times. So when you will do it, you will get 2 into 2 into 2 into 2. It means 2 to the power 4. If any number is written for 4 times, we will write 2 to the power 4, 3 to the power 4 or 7 to the power 4 like this. So you will get 2 to the power 4 multiplied by 3 by 4. And when you will cancel out 4 and 4 in the numerator and denominator, you will get 2 to the power 3, that is 2 2s are 4, 4 2s are 8, and your option C is correct. Let's see the second part. 16 by 9 to the power minus 1 by 2. You do not need to touch the exponent, just see the base. 16 can be written as 4 into 4 and 9 can be written as 3 into 3, which is 4 by 3 to the power 2 multiplied by minus 1 by 2. And when you will cancel out 2 and 2 of the numerator and denominator in the power, you will get 4 by 3 to the power minus 1. Because the power is minus 1, you will change position of 3 and 4, the numerator and denominator. You will get 3 by 4, option B as your correct answer. The question number 3 is in the form of decimal where it is 0.00032 to the power 3 by 5. First, we need to convert it into form of fraction. So you will cancel out the decimal and you will get 32 by 1 and 5 times 0. Because the denominator of the power is 5, so you need to break off 32 and 1 lakh into the power of any number where you are getting 5 factors. So you will keep 2 for 5 times in the numerator and 10 for 5 times in the denominator. You will get 2 by 10 to the power 5 multiplied by 3 by 5. And when you will cancel out the numerator and denominator 5 by 5, you will get 2 by 10 to the power 3. You can simplify 2 by 10 as 2 1s are 2 and 2 5s are 10. So you would get 1 by 5 to the power 3, which is nothing but 1 upon 125. So your option C would be the correct answer. Let's see the fourth part. It is 1 upon 5 to the power x is equal to 0.008. Till the time you were getting only the numbers, but now you got a variable x here in the power. So don't worry, don't get confused. We will just do simple methods. What? The first thing is convert this 0.008 into the form of fraction. When you will do, you will get 8 by 1000. And on left hand side, we will keep 1 by 5 to the power x as it is. We will not disturb it. When you will cancel out 8 by 1000, you will get 1 upon 125. And then when you are converting 1 upon 125, you could get 1 upon 1 to the power 5 to the power 3. This way, the base 1 by 5 and 1 by 5 is same on left hand side and right hand side. You can say the value of x, which is a power, is 3. When the value of x is 3, you can simply put the value for 27 power 1 by x, that is 27 to the power 1 by 3, or when you will solve, 27 can be kept as 3 to the power 3, or when you will cancel the numerator and denominators 3, you will get 3 as your option. B is the correct answer. Then question number 5, it is 11 to the power minus 2 whole power 2 upon 11 to the power 2 whole power minus 2. In this case, you can multiply the powers of numerator and denominator. You would get 11 to the minus 4 in the numerator and 11 to the power minus 4 in the denominator. Because this fraction has same power, so we will cancel out. We will get 1, option B as our correct answer. Now question number 6, it is root of 11 to the power 4. It is 11 to the power 4 and root can be taken as the power half, right? So 11 to the power 4 by 2, when you will cancel out 2 2s are 4, you will get 11 to the power 2, which means 11 written for 2 times. Then 11 11s are 121, and in this case option B would be your correct answer. Question number 7, which is 5 multiplied by root of 27 to the power 2 by 3 plus 8 to the power 2 by 3. As you can see, the denominator of both the powers is 3. We will try to convert 27 and 8 in the power of 3 of any number. You will get it like 5 root of 3 to the power 3 power 2 by 3 and plus 2 by 3 to the power 2 by 3. Then when you will solve, you will get 5 root of 3 square plus 2 square. After solving 3 square, you will get 9 plus 4, and that is root 13. So 5 root 13, option A would be your correct answer. Let's see question number 8, that is 10 to the power 325 and 10 to the power 327. We know when the bases are same, if the base are in the division, then the powers get subtracted. So we will keep 10 as the base and power 325 minus 327. Because 327 is greater, we will keep 10 to the power minus 2. Or we can write it as 1 upon 10 to the power 2. When we will multiply, we will get 1 upon 100, that is nothing but 0.01 after converting into decimal. So your option A would be your correct answer. Moving to question number 9, that is 5 to the power 5 minus 5 to the power 3. So 5 to the power 5 means 5 written for 5 times, and 5 to the power 3 means 5 written for 3 times. When you will solve it, you will get 325 and 125. When you will subtract, you will get 3000, option C as your correct answer. Moving to question number 10, it is 16 to the power x by 5 is equal to 256. Now, because your base is 16, you will try to convert 256 in the power of 16. After dividing, you will see that 16 multiplied by 16 will fetch you 256. That's why we can write it as 16 to the power x by 5 is equal to 16 square. Because the bases are same, we will compare the power. X by 5 is equal to 2, and then 5 will go in multiplication of 2. You will get x is equal to 10, and hence your option C would be your correct answer. I would recommend you to play this video again from the starting and try to get the concepts that when the bases are same, their powers get compared. When the bases are same and are in multiplication, their powers get added. When the powers are same and the base is also same and they are in the division, then they get subtracted. Now let's move to next exercise, that is exercise 1.2 of this same chapter, surds and indices. The first question of it is 6 square multiplied by 6 to the power 3. As I told you, if bases are same and they are in multiplication, then the powers will get added. So it would be 6 to the power 5. It means you have to write 6 for 5 times, and when you will do it so, you will get 7776, option C as your correct answer. Question number 2 is 9 to the power 6 multiplied by 9 to the power 5 multiplied by 9 to the power minus 9. All of them have same base 9 and they are in multiplication. So we will write the power as 6 plus 5 minus 9 because this third power was in subtraction. When you will solve it, 6 plus 5, 11 minus 9 would give you 9 to the power 2, which is 9 written for 2 times, and 9 9s are 81. Option B would be your correct answer. Moving to the next, third question, it is A is equal to B to the power x, P is equal to C to the power y, C is equal to A to the power z. We are going to start with the first part, that is A is equal to B to the power x. In place of B, we will put C to the power y. So A is equal to C to the power y whole power x. Or again, in place of C, we will put A to the power z. We can also say it as A to the power 1 is equal to A to the power x, y, z. As I told you, if the bases are same on left hand side and right hand side, the powers get compared. So you will get x, y, z is equal to 1. Option B as your correct answer. Question number 4 is x to the power a upon x to the power b whole power a plus b into x to the power b upon x to the power c whole power b plus c into x to the power c upon x to the power a whole power a plus c. If you will focus, the x and x in the first term is nothing but in division and their base is same, so we can write it as x to the power a minus b whole power a plus b, then x to the power b minus c whole power b plus c, then x to the power c minus a whole power a plus c. And if you remember the identity, a minus b into a plus b will give you a square minus b square. So it would be x to the power a square minus b square into x to the power b square minus c square into x to the power c square minus a square. And because the base x is same in all the condition, we will add all the powers. You will get a square minus b square plus b square minus c square plus c square minus a square. All the powers are same and can be cancelled out by one and another. So you will get x to the power 0 because you have nothing left in the power. And if any number or any variable has 0 as its power, so answer is always 1. So the option B would be your correct answer. Moving to question number 5, that is a to the power minus 1 upon a minus 1. A to the power minus 1 can be written as 1 upon a minus 1 upon a minus 1. When you are taking the LCM, you will write it as 1 minus a upon a multiplied by a minus 1. After taking subtraction sign, means minus sign as common, you will get a minus 1 in numerator and denominator both. After cancelling it out, you will get minus 1 upon a, option B as your correct answer. The sixth part of it is 5 to the power a is equal to 3125. What you need to do, simply take the LCM part of it and find the factorization of 3125 into the terms of 5. You will get 5 to the power a is equal to 5 to the power 5, which means a is equal to 5. When a is equal to 5, put the value in the question, that is 5 to the power a minus 3, which is 5 to the power 5 minus 3 or 5 square. 5 square means 5 multiplied by 2 times, which is 5 5s are 25, and option A would be your correct answer.